This is the video for explicit formulas for arithmetic and geometric sequences. At the end of this lesson, you will be able to write an explicit formula that describes how to get to any term in an arithmetic or geometric sequence. Before we get to your worksheet today, I'd like you to take a look at this sequence. We go from 12 to 7 to 2 to -3. Do you see the pattern here? In this example, we are adding -5 to get to our next term. So here we can see a pattern. Can you imagine if I asked you to find the 100th term of this sequence? We know from our lesson today that in order to find the 100th term, we would need to know the 99th term. In order to find the 99th term, we need to know the 98th term of this sequence. Can you imagine if I asked you to sit here and list all of your terms until you got to the 100th term? I bet you could do it, but it would take a pretty long time. So today, we are going to come up with a shortcut or a formula that will help us find the 100th term in this example. So an explicit formula is different than recursive. This one is more common, and we're going to be using this quite a bit. So an explicit formula tells you how to get to any term in a sequence. There are two requirements that you need to know in order to write an explicit formula. So as long as you know the first term in your sequence, which we are usually always given, and if you can identify the common difference or ratio, then you can come up with this formula. So there is an explicit formula for arithmetic sequences, and there's an explicit formula for geometric sequences. It says down below that these formulas can be found on your reference sheet. You have not yet been given a reference sheet this year, but in class tomorrow you will get one. So you can always refer back from now on to your reference sheet when you need to come up with these formulas. So here they are. To get to any term in an arithmetic sequence, so remember any term, we will write a sub n. We are going to use the first term, a sub 1, and then we will add, in parentheses, we will take n, whatever our term number is that we are trying to find, and subtract 1 from it, and then we will multiply it by the common difference. So this formula, after you use it quite a bit, you will get very familiar with it, or again, it will be on your reference sheet that you'll get in class tomorrow. The geometric sequence is going to be to get to any term in this sequence. As long as you know the first term, we will take the first term and multiply by the common ratio. And then we will raise the common ratio, whatever that number is, to the n-1 power. Okay, so let's take a look at some examples. Number 1. This was a sequence that I had put on the previous page when I asked you to find the 100th term, and now we're going to see how we can use the explicit formula to find the 100th term. So we don't have to sit here all night to find this value. So first we must identify if there's a common difference or a common ratio. We said before that we are adding -5 over and over again to get each new term. So we know here, let's always identify it, that it is arithmetic. And for letter A, the common difference, D, is -5. We said up above that you can come up with the explicit formula as long as you know the first term of your sequence, and in this example, the common difference. Well, we do know the first term, and it is 12. Let's record that also. So we know the common difference is -5, and let's jot down that our first term is 12. So when we are asked to write the explicit formula, we're always going to use our explicit formula from our reference sheet or up here in your notes as our guide. So in this example, to get to any term, we will take the first term. Well, we know what a sub 1 is, so I am going to write that the first term is 12. We will add, in parentheses, n minus 1, and then multiply by d. In this case, it's negative 5. I'm going to make sure I put negative 5 in parentheses to show that we are really multiplying by negative 5. Otherwise, it would look like subtraction. So here you have it. This is your formula that tells you how to get to any term in this specific sequence. So let's find that 100th term. A sub 100. So this means that 100 is taking the place of the letter n. So I'm going to use the formula that we created for this sequence to find the 100th term. So everywhere I see that letter n, I will replace it with 100. 12 plus n minus 1, I'm going to substitute one step at a time, replace it with 100, and then multiply by negative 5. Now I am evaluating, so I'm going to do what's in parentheses first. So 12 plus 99 times negative 5. It is so important here that you follow PEMDAS. So I see my addition sign here, but I do have multiplication over here. So use your calculators, please. 99 times negative 5 is negative 495. Yes, you may write plus negative 495 if you wish to instead. So now we have 12 minus 495, which is equal to negative 483. I'm going to bring down this a sub 100, or the 100th term, and I should really put it on every line above as well. So there we have it. The 100th term of this sequence will end up being negative 483. Let's try the next one. So we have a sequence here. We must find that pattern. Here we go. Remember, I could see this negative, positive pattern, which signals that we are multiplying by a negative, if anything. So to get from negative 1 to positive 6, we would multiply by negative 6. Let's check it again. Is 6 times negative 6 going to give you negative 36? It sure does. And if you checked it over here, it would also work as well. So let's mark this up. Multiply by negative 6. Since we are multiplying, this is a geometric sequence. State the common difference or ratio. Ratio goes with geometric, so our common ratio is negative 6. Now we are coming up with the explicit formula. Please take a look at the top of your page where we wrote down our geometric explicit formula, and we are going to use this as our guide. We are always replacing a sub 1 and the common ratio. Same thing from up above. We're always going to replace a sub 1 and the common difference when we come up with our specific formulas. So in this one, to get to any term, we use the first term. In this example, it's negative 1 times r, the common ratio. It's negative 6. Please get in the habit of always putting your common ratio in parentheses. That may help you out later on. And to the n minus 1 power. So this is our formula that we will use to get to any term we wish to in this sequence. Even if we wanted to get to the 500th term, we could. So letter C, we need to find the 10th term. Notice that 10 is taking the place of n. So to find the 10th term, we are replacing 10 with n up here. Equals negative 1 times negative 6, 10 minus 1. Now when we are working with the geometric explicit formula, we are always going to work with our exponent first right here. So negative 1 times negative 6, and that will get raised to the 9th power. I'd like you to use your calculator now. We must do our exponents, so negative 6 to the 9th power. Please make sure that you put negative 6 in parentheses. That is very, very important. So if you do that, negative 6 to the 9th power becomes negative 10,077,696. Lastly, we must multiply by negative 1, so it's just going to become a positive. And here you have it, the 10th term of this sequence. Notice we really didn't go all that far, it's just the 10th term, but we get a very large number. That's going to happen with geometric sequences. They're going to grow or decay very quickly. So there are 2 more examples on the back of this worksheet. Nope, 3 more. So let's do number 3, and then you can do the U tries. So 1 more. Together we have here a sequence. See if you can spot what is happening from one term to the next. And if you guessed that we are adding negative 1.1, you are correct. So check that out on your calculator if you were not able to come up with that. And so on. So, arithmetic, it is a common difference, D, and it's equal to negative 1.1. Write the explicit formula, so we will use what is on the front page of our worksheet, and we are going to replace, like we did before, the first term and our common difference. So in this example, to get to any term of this sequence, the first term, in this case, is negative 12.5 plus n minus 1, and we will plug in the common difference, in parentheses, negative 1.1. Now we are going to find the 38th term. So n is 38. To find the 38th term, we will take negative 12.5, add it. We are replacing n with 38. One step at a time, minus 1, and then multiply by negative 1.1. Here we go. This becomes 37 times negative 1.1. Similar to before, we must multiply these two first, so we are following our rules of PEMDAS. We end up with negative 12.5, and this is going to end up being a negative, so I will write minus, and test it out on your calculators. It is negative 40.7. So, negative 12.5 minus 40.7 comes to negative 53.2. Which means the 38th term of this sequence, if we continued the pattern, would be negative 53.2, or 2/10. And let's just fill this in on each line. So, now that we went through those examples, you are going to try numbers 4 and 5. So please press the pause button. When you press play again, the answers will appear. Please pause. Okay, so at this point you should have completed number 4 and 5 on your own using your explicit formulas on the front of your page. Here's the answer for number 4. Make sure you take a look at each of your pieces. Make sure your formula is correct. And in this example, the 8th term of the sequence would end up being negative 384. Number 5, was an arithmetic sequence. Here was the explicit formula. We are finding the 30th term, so when you plug in 30 and evaluate using your order of operations, this says that the 30th term is 219. Please write down any questions or comments that you may have about this lesson. We will practice more tomorrow and in the next couple of days. Thank you.